Hi again. So this is the fourth and final method to factoring. Quick recap on the three that we've already done. The first method we ever talked about was GCF. Second method was for grouping, which you use only if you have 4 terms. The third method we just discussed was guess and check, and you use that for trinomials. Now, binomials. How to factor if you only have 2 terms. When you factor a binomial, as you know, a binomial has 2 terms, and if there's 2 terms, there's 2 rules. The first rule, the 2 terms must be a difference. That means the 2 terms have to be subtracted. There has to be a minus in between the 2 terms. The second rule is that you must be able to take the square root of both terms. You must be able to take the square root of both terms. I know we've never formally done square roots in class. So quick lesson on square roots. Quick lesson on square roots. Square root of 16 is 4. Square root of 25 is 5. It's 4 because 4 times 4 is 16. 5 times 5 is 25. Square root of 100 is 10 because 10 times 10 is 100. Square root of 1 is 1 because 1 times 1 is 1. Square root of x squared is x because x times x is x squared. And the square root of x to the 4th is x squared because x squared times x squared is x to the 4th. If you can handle these, that's all you have to know about square roots for now. Let's bring back this. Okay, this has a special term, a special name. When you're factoring a binomial, the 2 terms is called a difference of squares. Factoring binomials is called a difference of squares. You ready? Here's number 1. 9x squared minus 16 must be a difference. Okay, rule 1 passes. It's a subtraction problem. Must be able to take the square root of both terms. Square root of 9x squared is 3x. Square root of 16 is 4. It passes the 2 rules. Can you see that this is a difference of squares? Both terms are square rootable. You can take the square root of both terms. This is a difference of squares. So here we go. You're going to love it. Set up your blank parentheses. Square root of 9x squared. Put a 3x here and a 3x there. Square root of 16. Put a 4 here and a 4 there. One's a plus, one's a minus. It doesn't matter. You can put the plus here and the minus there. It doesn't matter. Just make one of them a plus, one of them a minus. And I'm done. But being the rock star student that I am going to check this. How do you check it? I'm going to FOIL that. 3x times 3x. 3x times negative 4. 4 times 3x. And 4 times negative 4. 9x squared minus 16. The check works. That is my answer. That's it. It seems pretty straightforward. It is fairly simple, but it can get tricky. Stay with me. This can get a little bit tricky as we go on. Do number 2. Pause me. Do number 2 on your own. Square root of p squared, square root of 36. One's a plus, one's a minus, it doesn't matter. Let's check it. P times p times 6, negative 6 times p, and 6 times 6, watch your signs. P squared minus 36, love it. There's number 3. Please notice with number 3, back in 11.3, when we were doing trinomials, I stressed the importance of descending order. Hold on, I'm coming. There. Do you remember this back in 11.3? You were given 24 plus n squared minus, and you had to rearrange it, make it n squared. You had to put that in descending order. Descending order is only for trinomials. Oops. Number 3, do not rearrange it. It's okay. That is not descending order, but that's okay. Leave it like that. Just dive on in. Square root of 49, square root of x squared. One's a plus, one's a minus, doesn't matter. 7 times 7, 7 times negative x times 7, x times, goodbye. 49 minus x squared, 49 minus x squared. Beautiful, there's my answer. Go ahead, pause me, do number 4. Square root of a, or square root of a squared is a. Square root of 25. What are you going to do if it is a plus? Do you make them both plus? That is not what we want. Rule number 1, must be a difference. This is a sum of squares. A sum of squares. A sum of squares is garbage. You can't factor that. You cannot factor a sum of squares. The answer for number 4, you cannot factor that. Number 5. You might be tempted to say prime, but it is not prime. Can you feel the GCF? There is a GCF. That didn't happen with your first 4. Look back at your first 4. There's no GCF here. There's no GCF. No, there's no. Number 5 is the first one in 11.5 that has a GCF. Handle the GCF. What's your GCF? 5. Take out your GCF of 5. Y squared minus 4. Don't stop. Can you recognize in the parentheses, what do we now have in the parentheses? Y squared minus 4. That is a difference of squares. Square root of y squared. Square root of 4. One's a plus, one's a minus. Doesn't matter. Y times y. Y squared minus 4k. Grand finale answer. Put it all together. Put the blue and the orange together. Your grand finale answer. 5. Y plus 2. Y minus 2. And if you really wanted to check the purple to make sure the purple matches the black, there's a couple ways you could handle it. You could foil, ignore that 5, foil that, then distribute a 5, or distribute 5 to the first parenthesis, and then foil. You should, either way, you should be getting back the black. If you're okay with 5, go on to number 6. Square root of C4, C2. Square root of 81 is 9. One's a plus, one's a minus. It doesn't matter. Feeling good? But if you stop and you say that that's the answer, that's a very good wrong answer. If you stop here, you're stopping too soon. Look in that first parenthesis. Can you recognize this is a difference of squares? You have to break down c squared minus 9. C squared minus 9 breaks down into c, 3. One's a plus, one's a minus. Can you factor c squared plus 9? How do you break that down? You don't. You cannot. This is a sum of squares, which is garbage. You cannot factor a sum of squares. Whoops. So that, you're just going to hitchhike on to your answer. Your final answer are these 3 parentheses. That's what's going to get you in this chapter. You're going to think you're done. This is a really common wrong answer. It's a good wrong answer, but it is wrong. You're very often going to stop too soon. You have to make sure that you're really finished. There's number 7. I hope you're feeling the GCF in the very beginning. Pull out the GCF. Don't stop. Break that down. Grand finale answer, put it all together. Bring back that GCF of 4, x plus 2, x minus 2, and we're done. There's your answer. Number 8 is the last one. You might be tempted to say prime. This is a sum of squares. It is a sum of squares, but can you feel that there is a GCF? See, where did we have a sum of squares before? Number 4. If you look back at number 4, that was prime because there's no GCF. But number 8, there is a GCF. You have to acknowledge the GCF. The GCF is 9. Now what? Can you break down x squared plus 4? Please don't. You can't break down x squared plus 4. That's done. This is your final answer for number 8. Reach out if you have questions with any of this stuff. It gets a little confusing, especially at the end. If we were in the classroom, there'd be some really good discussions. So reach out to me if you want to fight about any of these. Bye.